Okay, welcome everybody. It is the 7th of December in Dallas, or the 8th of December if you're further ahead in the time zone around the globe. This is Dallas Personal Robotics Group, Robot Builders Night Virtual. And we're just going to do a casual go around the table as we usually do, talk about our projects and the like. And up first, we have John, who has a request for some kind of expertise in hardware. So John, take it away.
Yeah, I was wondering if anybody in the group has a lot of experience debugging hardware on an I2C interface. The situation I'm in right now is on our collaborative motor driver board project. I've got a board with the board's based on RP2040 with some additional hardware for the motor driver. And I'm making a comparison between a working system where if I take a Raspberry Pi Zero and hook it up to a Raspberry Pi Pico. The Pico's obviously it's 2040 processor, right? And connect the I2C interface, put some test code on the Raspberry Pi, I can read and write across the I2C interface to a register on the Pico. If I take that exact same code from the Pico and instead put it on our RP2040 board and hook up the I2C interface, essentially running the same version of MicroPython and the same, basically everything is as much the same as possible except the physical wiring and of course the board layout. I can't get it to work. Just having a lot of fits trying to debug that. Trying all sorts of different things, but everything that I've looked at so far comes down to I've got everything as much the same as possible, and it still doesn't work on our driver board. Even though, well, it sort of works in that when I do reads and writes from the Raspberry Pi to the driver board, I don't get any I/O errors. I don't on the Pi like I would if the interface was just not connected or responding. I just don't get the right data back. So instead of a mix of zeros and ones, when I read data, I get all ones. So just to show you what that looks like, let's see, share screen. I've got my bitscope hooked up. Here's a read sequence that does not work. And it's kind of funny because the symptoms seem to change a little bit each time I try this. I don't know how well you can see that, but the green line is the SCL serial clock. And the yellow line is the data. The odd new symptom that I get when I run this is every time the data line goes high, it also pulls the clock line up a few millivolts higher. And so obviously the two signals are not quite independent, although this is the first time I've seen this behavior. I didn't see this before. Suddenly it just started doing this. One of the other things I've noticed is that there's a difference in the characteristics of the two signals that got, in Bitscope, it shows you a DC voltage bias. On the A channel, which is the data, it's always right at around 1.7, 1.8 volts. But if I compare the waveforms between the working case where I'm talking to a Pico and the non-working case where I'm talking to our driver board, I've noticed that the B channel DC bias is different. It's higher in the failed case, and it's considerably lower when it's working with a Pico, somewhere around 1 volt instead of close to 2 volts. So I'm kind of at a loss to understand these weird symptoms. Does anybody have any insights?
I would suggest looking at the grounds.
Yeah, I did measure the voltage. I disconnected the I2C interface and then measured voltage between ground on the Raspberry Pi and ground on our driver board, and I only get about 8 millivolts difference, which I assume is acceptable for a ground.
They just got to be connected. I mean, whatever, both ends of the communication, the grounds have to be shared.
Well, yeah, well, I disconnected it just to show that there wasn't any kind of ground loop, but I have the ground running, but there is a ground line running between the driver board and the Raspberry Pi Zero. They do share a ground when I connect them.
And the power supply.
They're running on separate power supplies. It's both powered by I2C and by USB.
Gotcha. Yeah. So the one that's referenced on the Pico board should be referenced to its power supply, and the Raspberry Pi should be referenced to its power supply. Let me think about how this. Then the second thing would be your pull-up resistors. It's all 3.3, right? So
It's all 3.3, and that's another thing I tried is there are no external pull-up resistors on either board because it's RP2040 based, and we're using the internal pull-ups that are provided by the RP2040 processor.
Mm-hmm.
So my first thought was, well, maybe we have a little bit too much of pull-ups if we've got pull-ups on both the Pi and the RP2040. I did try putting in some 4.7K pull-ups. I basically broke the line and got in there and added 4.7K pull-up resistors. That didn't change the outcome. It did raise this B channel bias up even further, up to like 2.4 volts.
But when you did that, you put everybody, you turned off the internal resistors on both ends, right?
No, I did not.
Okay. Well,
The thing is, one thing, that's the next thing I was going to try is maybe the problem is if I got pull-ups on both ends, maybe there's actually too much pull-up resistance.
Yeah, it could happen. Pull-up resistors can be tricky, especially if you have a lot of sensors going on.
But the only place in the case with my board, the only place I can turn it is I can't turn off pull-ups on the Raspberry Pi, on the Pi Zero. That's a constant, but I can turn them off on on both our driver board and on the Pico that I'm using. The really mysterious thing is why. I mean, our board design, half the board is based on what they call the RP2040 minimal design,
right?
Basic, which pretty much replicates most of the hardware that they have on a Pico board.
Mm-hmm.
So yeah.
You're saying the data is 0, but is the address coming across okay?
Oh yeah, it's addressing the board.
Yeah. So
it's just when the data comes when I read data back, I'm expecting a mix of 0 and 1s. I get all 1s. The Raspberry Pi Zero only sees 1s coming back, and there's a mix of 0 and yeah.
Usually when I'm trying to troubleshoot an I2C, Pat showed the right thing. I think it's a little. What's the name of that little thing, Pat? What they call it? I can't hear you.
You're muted.
You're muted. You're muted.
It says logic analyzer on it, but it's just a little logic probe.
It's a clone of something, and I can't think of what it is.
Yeah.
Yeah.
Oh, the say logic. So it's a logic analyzer.
So yeah, it's just a logic analyzer, and I'm using it with
but anyway,
Pulse View software.
Yeah, and I usually use the I think it's Sakine or anyway, I used whatever the original came with because they had it. They don't open source it, but they allow you to use it, and it had.
Okay, Doug, you're cutting out, or you've cut out. Doug, you're totally cut out.
Well, I have a logic. I'm using a Bitscope logic
Yeah.
analyzer.
Yeah, notice that. I was going to suggest another thing. I haven't, I2C is on my list to play with, but I haven't yet, in all this full disclosure. But I have purchased one of these little guys, and I'll put the link in here. But this is basically some cool looking. The reason I got it is that it's basically like a bus analyzer specifically made for I2C. So I don't know what all exactly you can do with
It
it.
turns all of those bits.
So is it something that you attach on a working I2C interface?
Or a not working one. I think you can use
Well,
it.
okay, let me rephrase that. It's a third component. You got a live interface, and then basically you're attaching it to the middle of that to do an analysis.
That's how I understand it. So you can put it on the
Actually,
bus.
I have one of those, and you can attach it because it's a bus. You can attach it anywhere on the bus, and it just shows the bus signals. It works really well. The only downside is that the screen is really, really small. So actually, it's quite good. I think if you had a desktop or laptop based one, it would probably be better. And the only problem with the thing is the screen is only this big, so it's really kind of hard to see what's going on. Because I played with that myself.
Well, what sort of things does it do that just a regular logic analyzer does not do?
Well, it's tuned for I2C. I mean, it's all it does. There's one for SPI and one for I2C, and I've got both of them. I've only used the I2C one. They work quite well. Like I said, you don't have any real control over it. You just get to see the signals, and there's a little tiny control. I mean, it's a display basically, but the display is small. That's all. But you can definitely see the signals.
It looks like you can, you can see the signals, and if you look at the link, you have to just decide if it might or might not help you with your issue. But it says that you can just watch and decode traffic. You can see what's happening kind of real time in Snoop. You can capture the traffic to your PC in a timestamped log.
Oh, I didn't know about that.
Well, I mean, that's what it shows on the site now. Maybe it didn't before.
Well, it sounds like the advantage that you have with that device is, normally if you're just looking at the raw signal in a logic analyzer, you have to kind of count the pulses to figure out which bit is which and which is the right bit, which is the ACK. I'm sure that what it does is help you identify the data and the protocol bits that are in there, but unless it does something specific about, okay, this voltage isn't quite right, or this time that this bit is high is not quite long enough, and so on. Okay, current voltage monitoring, that might be useful.
Yeah,
That's
the thing, right? So it's like it appears to be designed specifically to help diagnose and troubleshoot I2C, and that's why I got it. So.
Well, as much problems as I've had with I2C in the past, in fact, almost every time I come up with a new implementation with I2C, it never works the first time.
Yeah.
That's just the way I2C is.
Yeah.
But I figured $30-40, and it's bound to have good support for the way it's intended to be used. So maybe
wasn't Murray pimping those just a month or so ago, or maybe a little bit longer? I mean, if it's got
that's the thing. I have both of them. Yeah.
Yeah, if Murray, if Murray's going to say it's good, I'm going to trust it.
Yeah.
That's all there is to it.
I
was
encouraged to
actually
get
being
one.
serious there, Murray. Believe it or not, I was really.
Oh, I appreciate that, Harold. I'm not sure I believe you. I don't know if I believe me, but okay.
I will say that the thing that Pat was holding up can do most of that too. And That's the reason why I originally got one, was because I don't like counting pulses. I like looking at the signatures, and it will tell you right off if you're dropping an ACK or you're not giving it the address you think it is, and all that. You can calculate, you can look at your data and make sure it matches what you think you're sending. So there are solutions. This one looks like a good one too. The other one basically does, instead of having a little nice display, puts it on your PC. So
Well, the one that
I'm just throwing out that might make it easier. And I think it's a little cheaper than $30. I think I paid about $7.50 for mine.
well, if you've got,
But I don't know what they're
if you
going
link to
for
both,
now.
I'll look at both. Although it would be nice if I could do it on the PC.
Yeah. Yeah.
Well, I think, and I haven't looked at Bitscope, but there was some open source logic analyzer software that worked with all kinds of different hardware, and some of those even have the bus analyzers and protocol analyzers as libraries you can plug in. So
Yeah.
if you had enough
That's
probes, you could just turn it on and it'll do the decoding for you.
yeah, that's what I was talking about.
I've had this Bitscope for something like 10 years, probably.
Mhm.
It's getting kind of dated.
Yeah.
Has anyone tried to use the in-call messaging? It's frozen.
What?
Try to send a message. See if it works.
I can't understand what you're saying.
Yeah,
Doug,
Ray,
can
I
you
think you're saying, Ray, have any of us used in-call messages? And I have been every week. When someone talks, I sit down and announce them, and we've had chats on there. So
Yeah, doesn't seem to be working today, at least not for me.
Okay, well, that's all I had. If nobody has anything else to add.
A lot of websites are down today because AWS is down.
Oh,
well, that's true. Although as Google, I would imagine that Google is using their own servers versus Amazon's, but
yeah.
but it could be a common problem like DNS router or something. But well, can anyone else see the things I put in there? Because I put a link to that, and I put some things in chat already. Can anybody not see that in the messages, the chat?
I
don't
see
it.
3 messages in the chat.
Oh,
Okay.
oh no.
I see 2 messages in the chat.
Well, if you came on after 7:42, then you'd only see the last 2.
That's what I see.
Okay, that's why.
I'm not seeing any.
It only shows you the messages since you arrived.
7:42, 7:51, and 7:52.
Okay. So Ray, not sure what's going on, but at least 3 or 4 of us have it.
Yep.
I
Okay.
see 4 lights. I see 4 lights.
I was wondering who was going to do that first.
Okay, well, cool. John, our hearts are with you. I hope it works. We're looking forward to whatever you can find out for next week.
Well, there's always just a simple possibility that the board is damaged. That when I put it in the oven and it overcooked it.
Darn it. Anything could happen.
Baked it for too long.
Anyhow, like I say, we're crossing our fingers for you. Hopefully it'll work out well.
John, are those open collector outputs?
Yeah, RP2040, when you set them up as, I understand, when you set them up for I2C, they're open collector.
I mean, doesn't that seem like it's the kind of general area of where the problem is?
I'm not certain. I'm not certain I follow you.
Well, that whatever value is being written, it's always driving it as a 1.
Well, yeah, that did occur to me. I was thinking, my current working theory is, since the Raspberry Pi has pull-ups, and we've got the RP2040 configured to have pull-ups as well, perhaps there's just a little bit too much pull-up current, and an open collector, you have to actually sync current to pull it low. So if you have too much pull-up current, then you can't pull it down to a low, and you're going to get all 1s. That's my working theory. Does that make sense?
Well, the fact that you have those two pull-ups in series is producing greater current flow. Is that your?
Parallel.
Yeah, more pull-up current.
I'm sorry, parallel. Thank you, Carl.
Yeah. So in order to get it zero, you have to sync that current through the pull-up resistor. Right?
Are there any other loads on that pin? Is it connected to anything else?
Nope. It's dedicated to the I2C. Of course, I could just take a soldering iron and do the board and rake it across the associated pins just to see if don't have some hidden artifacts under some of those components. Put lots of solder flux on it.
Well, or you could, for that matter, I was thinking if you could power the board up, the suspect board without the bus connected, and if you could make it write the bits high and low, you could see if there's a short in the board that way.
Yeah, well, I did basically arm out with the board powered down. I did arm out a lot of connections just to show there were no unexpected shorts.
I don't think it would be an issue. You said 4,500 ohm pull-ups?
Yeah, I added 4.7K pull-ups to see what it would do, but it didn't fix it.
That's in parallel with the weak pull-up that's already in the Raspberry Pi and the other board.
Right.
I don't think that would make much of a difference. Your current is probably still under 1 milliamp to sync to ground on your pull-up.
Yeah, well, we'll just keep soldiering on. Oh, by the way, I don't know if I told you about my first board, where I populated the entire board. And there it is right there.
Ooh.
This one did not work at all because when I plugged it into my USB, within about a minute, it got too hot to touch. And I was afraid it was going to burn out my, obviously there's something wrong with the board, but I've armed out everything and I can't find it. But clearly you should not be drawing that much current. The new one that I put together, the strategy was to keep it simple and to populate just the RP24 components first, which I did, plugged it in, didn't get hot. So then I added just one driver section components after that, verified that it still didn't get too hot. So I was like, okay, good. At least I don't have some potentially catastrophic failure, power to ground or anything. And that's when I started testing I2C. But this one is basically a write-off.
Prototype pile it is.
And that basically took up one of my two RP2040s that I have. So I'm waiting in a couple of weeks to get about 4 more.
Well, isn't it Ackley's rule that the third one you'll get it right?
We'll test that. We'll see. It could be a board defect. Maybe I just got to put another one together and see what happens.
Nice.
But I did already find one of the guys in our collaborative group did identify one fault on the prototype. I've only got one of the two motor voltage inputs wired on the driver, so it can only handle half the current. I was skeptical that this thing would handle the current that up to 5 amps, because that part is incredibly small. The driver is incredibly small. It's like probably 3 millimeters on an edge, 3 millimeters square. I'm going, how could that thing possibly handle 5 amps? Oh, it's got two
Pins.
motor voltage inputs, and I failed to connect one of them. Live and learn.
All right. Yeah, well, so I heard Ackley's rule of 3 moments ago, which is a fantastic segue because Mr. Dave himself, the man, was next in queue to tell us about his new board. So Dave, what do you got?
All right. let me see if I can show something here.
But he's probably got 3 new boards, right? Because,
Not sure what's wrong with this.
We see a
wow, $95. Jeez.
Citron.io Pi Maker Pi
Yeah,
RP
I'm not sure
24.
what's wrong with the picture. It's the way he
Looks
did
fine.
that.
Dave, I think it looks okay to me.
Yeah,
Okay.
me too.
I see a web page.
It's way dimmed out, but that's all right. Anyhow, this is the board I have, and let me see if I can actually show the board I actually have here physically. There.
Should we pin you? Dave, it sounds like your voice cut out.
Okay.
You see the box?
I see a very pink box.
Okay. Well, I have a second. You may not be able to hear me now. I've got.
We can hear you.
Yeah,
Okay.
now we can.
I've got a second camera here, but I'm not sure how to get it shut.
On the bottom of the screen, 3 dots, more options. And then under there should be settings. And under there, video. And then you can select whichever camera you want.
Okay. Settings. Video.
And then it should blank out briefly and switch between them.
Okay, video.
Yep. And under the video, there should be a drop down with however many cameras you have. Like I have 2 physical ones and 7 virtual ones.
Okay. About that. Nope. Yeah. That one.
But you're presenting. So, okay. Yeah. So if you unpresent, then your camera, when you talk, will take focus.
Okay. Let's do a present. Okay. And I don't see me.
Nope, don't see it either. Oh, there.
I don't. Do you see anything?
Yeah,
It's on
we see the box, Dave.
Oh, you see the box. Okay. Well, I don't see it, but that's all right. Anyhow, this is the actual board, and in the box is the board. Hopefully, you can see that.
Yep.
And let me get it out. Let's show comparison. Here's how it compares with a Arduino and a Mega.
Could you shift them to the left?
Closer to your keyboard.
Could you shift them to the left? So we see the Mega and the other left.
The other left. Okay.
A little bit more. Okay, there we go. Mega, Uno, and this new one in the middle. Nice.
Yep. Okay. Now, I will try to demo the new one, but unfortunately, the brightness or the quality of my camera isn't quite what it needs to be to do a good demo of it. But Is it in? Can you see the board?
Yeah.
Okay.
Mhm.
You turn it on, it runs through it goes ahead and lights up the 13 or so digital pins, and it shows different colors on the RGB, and then you can also, on the board, it has these switches so that on the actual power to the motors, you can actually turn on the individual drives, either positive or negative. And it has then two user buttons that allow you to do different things, and the board as it comes, which has Circuit Python on it. It runs a demo and turns on and off things. So it's a very powerful board. It has two motor drivers, four servo drives. It has a buzzer. It has these seven connectors that hook up to the 13 I/O pins that allow you to do two spies, two I2Cs, various other things. The idea is that it uses at the base a Raspberry Pi Pico, and so it's pre-programmed with Circuit Python, which is pretty powerful, and this board runs $9.99. You can buy it from digital, and it's also available from Adafruit for $12.50. They have it in stock. Anyhow, I got mine from DigiKey, who stocks them, and it looks to be a pretty powerful board for almost everything that you would want to use the board for. And it's now it can actually be programmed in C++ because a Arduino Pi Pico can be programmed in C++, Python, MicroPython, CircuitPython, or Arduino. So you've got a lot of options on how to program it. The board comes with CircuitPython on it. I'm planning to use it with MicroPython because MicroPython provides a lot more capabilities. In particular, it allows you to do cooperative multitasking, and allows you to get a full cores, and allows you to do programming the I/O parts of the Arduino, Raspberry Pi, Pico, and so it's a really powerful board, and it looks like to be a really good board to start doing a robot with. Anyhow, that's all I had.
Yeah, I agree. And since Dave brought this up in the list for me, and I looked at it, and it's also available at the $12.95 price from Mauser if you want to do it there. But DigiKey is definitely the cheapest way to go. Plus, they have USB, United States Postal
Delivery.
shipping, so it's only like $4.95. And so I went ahead and picked up a couple of these. And I think if you didn't have any Raspberry Picos, this would be the way to go, because you couldn't put this additional capability for $5. It's an incredible board. I hate Grove connectors, but hey, I'd live with it on this one.
In case I can confirm, if anybody was wondering, like I know you were, that if you wanted to make the drive down to Mauser and just skip all that shipping stuff, the will call window is open now. it wasn't for a long time.
Oh, yeah, that's great.
All the way down to Mansfield.
Well, from
What else you got to do, man? What else you got to do, Ray? Come on.
my house, it only takes me about 15 minutes to get down there. So I'm glad that will call windows back open.
That's your, John, that must be your version of what we had at Tanner's then.
What?
Just drive on out to Mauser, you get whatever you want.
Yeah. I suppose if you have a lot of people at work like Mauser, you can pile into a car and make a group trip out of it.
Excursion.
It could
Oh,
be
cool.
an hour and a half one way for me, at least.
Mr. Dave, that's pretty cool. Glad. Thanks for that. We'll see who. Are you going to do anything with that new board of yours, or just write some code and watch the blinky lights? Oh, you're muted. You gonna add a microphone, Dave?
There we go. I'm going to, first of all, see if I can do the blinky things with MicroPython instead of CircuitPython. So far, I've been able to turn those 13 lights on and off, but it looks like it's, that's where I'm going to start. I'm going to try to do some various displays and what have you, just as a baseline, and then from there, maybe get around to doing a robot. The inexpensive double T motors that have the encoders, I've got several of those, and so I'm going to use those as the basis and go from there.
Cool. Sounds like a plan. All right. Moving on, I think I was next in queue with a really brief one. Then we had Doug D, Pat C. So, but I'll be fast. So, I did not have a chance to do much of anything. However, somebody sent me an email about this silly little repo that I did. So if you've seen, like, for the hover sim that I use, I just use this from Link's Motion, but generic PS2 controller, and then a dongle, and it has all the buttons and the two joysticks. So, but the default library, somebody, Ed, I'm going to mute you if you don't mind. But the default library that was available was having some issues when I got into it. So I went into the library and I made some changes, and I parked those changes 2 years ago, and I left it in a public library, and lo and behold, I got this email from a guy who had basically just said, thank you. He'd tried several different libraries and they all had issues, but he tried this one and fired up and just worked. So I asked how he learned about it, if it was through the Robot Club or not. And actually, no, he had learned about it by searching for PS2 libraries in GitHub, and this one popped up. And that guy happens to live in India. So never had that happen before. So that's kind of cool. And that's about all I have to report. So if you need a PS2 library, I got one endorsement already, and you're welcome to try it, and I'll help you with it if you need.
Oh, by the way, one of the things that comes with this Maker PI board is that you do get 4 of the Grove connectors with pins on the end. So it's not quite as bad as having to fight with Grove by yourself.
Pre-made cables, who can argue with that? Okay, on next in queue, we had Doug D.
So I wanted to talk about my experience with my telepresence robot, and I've been having a lot of trouble with it, and finally decided I'd go back to my prototype and see if my programming was wrong or my hardware was wrong. And let me present.
Dave, I'm going to mute you again because your microphone was ringing on us. So remember to unmute if you want to talk.
Let me get to the screen. I should be sharing my screen with the forward, left, and right buttons on it now.
Yes.
Mm-hmm.
And on my main camera, you should be able to see my prototype, which is the Roby that Howard was so nice to give me, or Harold, I'm sorry. And it's a mess, but it works. So when I hit the forward, if I turn it on, great.
If that's a mess, you've got a pretty relaxed definition of messy.
Let me see if I can play this again. Oh, darn it. I got my sequence off, and it looks like I just lost my video. I'm going to stop presenting. I didn't get it on the street before it crapped out, so I don't get a gold star, but it works. My battery for the Pi is really low. You may have seen it complaining at the top of the screen. I was busy powering up before my turn, but I didn't get it powered up enough. I'm sorry. But anyway, I got back and plugged all this in, and it just works. Unlike my one I've been building, which just does nothing when I hit the button. So clearly I've got a wire plugged in the wrong way. So I'm going to unplug all the wires and go back in again. The last time I had this trouble, y'all told me, well, the grounds aren't connected, and that was true. I plugged the grounds in between the two units, and it started working fine. And then after a couple of vacations, when I tried it again, now I've got nothing. So I must have moved something around. You know, these things happen. And the other thing that I discovered, though, I was very interesting to discover that my plan with the VNC, it works great if I have a monitor attached to the Pi when I power it on. If I have no video HDMI attached, it can't show the desktop from the remote VNC. And I haven't tracked down why yet. There's probably a reason.
I suspect it's because if you don't have a monitor, the X window subsystem won't fire up.
That's
You
probably
can buy
what-
dummy HDMI adapters from Amazon for about $2, $3, $5 that are expressly designed for that. Make it think
Good to
there's
know.
a monitor attached.
Yeah, good to know. 'Cause
I have
was planning on having
I have a
streaming
Raspberry Pi
anyway, so it
running
wasn't
headless
gonna be an
since I
issue.
built it, and I go in with
Yeah,
VNC no
that's I
problem.
thought that was the purpose of ENC, that so you could do something headless.
Yeah, so if you go into
Yeah.
Raspberry config and you enable the VNC server, and then you go into Raspberry Pi config again through an SSH shell the first time, you enable the VNC server and then go in through Raspberry Pi through SSH to Raspberry config again and enable a resolution on your monitor.
Yeah.
Even though there's no monitor attached, you should be able to see something when you try to connect.
Okay, I can try that. I'm actually going to have a monitor on mine, so it wasn't an issue, but right now I don't, so I keep plugging it in to boot it up, and that's how I discovered it. So I hadn't done any debugging to see why this is happening. I just happened to notice the last couple of times I played with it. If I didn't get it plugged into the monitor in time, it would never, I'd see the monitor even after I plugged it in later. I have to plug it in at boot up.
So the other one is in your config.txt file. I think there's an HDMI safe boot or something, and you can turn that on. It'll force it to put video out the HDMI, which may help with setting that up as well.
Okay, cool. I'm glad that I brought that up because I almost forgot to bring it up. So anyway, that completes my brief discussion. I just wanted to mention that I'd gone back to it and it was happily doing what it was supposed to.
That's
Except
pretty cool.
not when I'm trying to demo it.
Darn batteries. It's always a battery, low battery somewhere.
So maybe I'll be able to start working on the software part of it again instead of beating my head against this hardware part. I'm probably going to flesh out the prototype and make it fully functioning before I go back to the one I was building. Just because I like to see the robot actually roll so I can work on the software.
Nice. Cool. All right. Well,
I'm
good.
muting myself.
Hey, you're
Next.
moving along. Well, I think next we had Pat and then Ray. So Pat, you've got some Pololu magic going on.
Yeah, I've got a sensor I bought, and it was working okay. And well, now I would say it's no longer working okay. So, can everyone see my screen?
Yep. Yep.
Mm-hmm.
So that's what I had bought, the Pololu 3-channel wide type of flight sensor. Set it up with I2C and had it working, and it was working not too well. I relocated the sensor a little farther away from the base, and it started working actually quite well on the left and the right channel. I was getting pretty accurate distances. I was having it average, I think it was 4 readings. It's an interesting little sensor, but the center channel, no matter what I tried, was always coming back at about 46, 47, 43 centimeters, or millimeters. Sorry, because sorry, I had divided by 10. It's centimeters, so about a foot or a little over a foot. It was coming back at. But I did manage while I was resoldering one of the connectors, because I had to revert it to the other side. And there's a little tiny trace on I believe it's the SCL on the board. And while cleaning up the flux, I think I managed to break the trace. So my sensor is now pretty much not working at all.
Oh, man. Brag when that happens.
Well, thanks for the update on that one, because I actually was looking at that on their Black Friday sale and didn't get it.
I had bought it through a Canadian retailer that I find I get a little bit better deal than if I would buy from Pololu. They're a reseller in Canada for Pololu. And what I'm finding is their exchange rate is a little lower than the bank would normally give you. And then you get the added discount of not having to ship from the US, which is expensive. So they bring it in by bulk to Canada, and then I pay $11-12 to get it shipped within Canada. So usually I'll bundle it up with a couple other things and have it come in. It's a nice little sensor, but like I said, the center channel, even with nothing in front of it, was giving me a reading of about 40 some centimeters.
Pat, that's a sad story.
I know.
I don't know anything about that sensor, but I have seen before in optically based sensors, sometimes there's a reflection path on the device itself. For some reason, the device itself is feeding back onto itself, and that would always give you the same value whether or not you had a.
Okay, Carl has the sensor up on the screen. If you can look at it, where he's got it positioned on the robot is essentially the same way I positioned it. So those are the emitters at the top. So they're in groups of 2. So the 2 on the right, 2 on the left, and 2 in the center. They come on at the same time. So each channel, left, right, or center, emits a light at one time. So not all 3 are on, or all 3 pairs. Now, if you could change pictures, Carl, there's a picture at the bottom of it. Somewhere there was a picture at the bottom of it, I thought.
Oh, there we go.
Yeah, so on the bottom, maybe you can blow that up a little, yeah. There's the 2 receivers. So essentially a left and a right receiver, and they'll get the light from the left channel, the right channel, or the center channel coming back. And the circuit board is dividing the receiver from the emitter. So I don't know how much crosstalk you'd get from from one to the other.
Well, suppose it's reflecting off of something nearby. Pat, you might want to take it off the robot, or maybe you've done this, and test it by itself just hanging out in space.
I did.
And did the center also not work in that case?
Yes, before it broke, the center did not work. So in the last picture you had up there, Carl, I think it's between the SCL pin and one of those little surface mount resistors. There's a trace. And I think I broke it on the fourth pin from the left, sorry.
But that would make everything not work, right?
Well, I think it's the clock line, I believe, the SCL line. And I'm not getting a response at all from it now.
But that, you suspect that's a separate and distinct problem from the fact that the two center always return the same value.
Well, it approximately the same value, the center channel. And
Still sounds like some sort of odd reflection getting back to the.
And that's what I thought. That's why I pulled it off the robot and I really hung it in the air, so it was pointing at the ceiling essentially, 6 feet away to say, okay, well, there's nothing in the way.
Any holes in the board?
Nope.
Light pipes?
Electrical crosstalk. I mean,
yeah. So I was surprised how easy it was to get the I2C working on it, and I had to reverse the clock and the data, but then everything plugged up and started working. So I developed it into my routine. So I was getting my ultrasonic distances and then getting my infrared distances and sending everything off by serial. And there was some flux on the board. I had to reverse the connector. So I reversed it to mount the board inverted the other way. And I was cleaning off the flux, and I think I damaged one of the traces. And it's super tiny. I don't know if I can get in there to try to solder it. I think it goes from the fourth pin on the left to the resistor, the second resistor on the left.
Yeah.
And it's tiny. Like that's only like a 1/16 of an inch between the two.
Yep.
W cubed wire wire.
Yeah.
Yeah, well, I have some 30 gauge wire. That's what I was going to try to do is lay it in there. And
Did you try the ohm meter and see if it was an open?
no, I didn't try my ohm meter on it. That might be an idea to try it from the resistor to there.
Yeah, usually Palula's pretty good about, technical support. If you, tell them what happened or which thought you did, they may have a suggestion on how to fix it.
Yeah, they're not real good at taking things back, though.
No, I'm not asking them. I damaged it. I know that.
I know. I mean, I'm just saying, they'll always charge a restocking fee or at the best.
Yeah.
So, and if they send you a bummer part, you're gonna have to be pretty convincing.
Okay.
Yeah, I'm just saying. But I would ask about the 40. I think you can, Pat, with just looking at the board. I bet you can tack a little piece of a very thin wire between one end of those resistors and the exposed pin head. Around the hole, there's a little bit of uncovered. You can probably fix that. But it'd be interesting what I would probably just ask them. You saw this thing about the two center pins being the same all the time, and see if they had an answer for that.
Yeah. Okay. I might give them a call on that one, just because.
Yeah, I mean,
I would move it one way or another towards the wall, and the left or the right would change.
Mm-hmm.
But the center, even though there was nothing for 15 feet in front of the robot, was still coming back as roughly the same as one of the two sides.
Yeah, if you hadn't have tested it, just pointing it up at the ceiling, I would have thought you could have gotten a board with one of the components slightly tilted so that it was doing a long range view of the floor or something. But if you pointed it at the ceiling, that should be pretty clear.
Yeah, and I tried reversing. I tried flipping the board as well, so that the emitters were on the bottom and the receivers were on the top, just to see if it would make a difference.
Didn't make any difference.
No.
Yeah.
I wonder if you could just cover up the center transmitters really well and see if it still read something even with the center transmitters off.
Yeah, well, I could do that. If I get it going again, if I get it going again, I'm probably gonna just set it up and use it with the 2 outside channels anyway.
Hey, Dave, I want to give you a shout out. I bought 2 of those boards, after you suggested them. And I didn't realize they came with the Grove connectors underneath the board. I would have ended up buying more additional ones, and it would have cost me even more. So I'm glad you showed those wires.
You mean you just now looked and found them?
Yeah, I mean, I pulled the board out. I looked at the board, and I said, "Wow, this is really cool." Definitely the way to go. But I never thought to look underneath the divider piece of cardboard that they had in the box to protect the leads.
Yeah, they got 4 Grove connectors with the split out at the end.
Yeah, and a little screwdriver too.
Yeah.
Anyway, definitely that's the way to go, guys, if you're going to work with the 2040. I mean, that's the best price. It's really a good deal. And when they throw in the connectors, that even makes it better, because if you buy those suckers, that's another $4 or $5.
Mm-hmm.
Yeah. So.
Okay. Hey, well, Pat, sorry to hear about the sensor, but good luck with the soldering rework. And
you can also buy a box of the crimp-on connectors too for fairly reasonable. I think $12 for 40.
Yeah, I'm always concerned. I don't know if I can handle those little JST connectors though. I have a hard enough time with the DuPont ones.
No, the little crimp-ons are about the same size as the DuPont.
Okay, well, I've got a special crimper for it. I guess I'll have to bite the bullet and try it.
Or you could just get a couple from somebody in the group that might have a box full.
Well, that's possible too. Yeah. Dave's come up with a lot of good ideas.
To give you a good price on it.
And now we know that Tanner's is being replaced by Ackley's.
Yeah.
Mr. Ray, I think you were next in queue. What's going on in mower world?
Oh, not much. Is Murray still on? Oh, there it is. Okay, I'm assuming he's there. He had asked about a board that had a reliable radar sensor on. I guess I should go into presentation mode here. Anyway, I saw this today. It was on Google, and it's basically a board that has an ESP32 on it and a radar part. And they, so basically you can use the board as what they're calling an anchor or a beacon. And you have 2 anchors and the third board, and you can get it, I guess, positioning within 4 inches. It's meant for indoor use. The radar part is the Decawave DW1000. I looked through the documentation. They tell you, kind of what resolution you can locate, the board at 4 inches. But I don't see anywhere where they tell you what the maximum distance is. And even, read on, some of the documentation for this DW1000 part. So, I think that's the thing most people would want to know, right away. It's like, okay, is this thing good for a mile or, a couple inches or something? But, so I don't know, maybe they'll realize that and publish what it's supposed to be or make it a little more obvious.
Ray,
But
I looked at that this morning. I didn't do as much detail as you. It wasn't clear to me if what they're doing is using the radar unit on that little board to ping another unit, or if they're scanning for another unit's radar output. If you just need two of them, then they don't just need the distance to the beacon or whatever you call it. They need the angle, right?
yeah.
So
Um,
like Lawrence does that with a spinning transmitter. So you know where it's spinning, so you know where you are in the. And that, since they call this a scanning radar, I wondered if it was something similar, but it wasn't clear to me how it worked.
yeah, it looks like they're doing triangulation. So I think you get like a received signal strength indicator as well. So, but I mean, some radars, you can go through walls and look at things, and so I was kind of curious, what the capabilities of this thing really were, and they don't seem to document that. So,
Well, I had a question. Oh, go ahead.
You're suggesting that that the beacon may not have to be in the same room as the robot?
well, I know some of the radar sensors that Andrew Spice or however you pronounce his name tested. He could sense that a person was on the other side of a wall, or like a glass, even a sheet of glass, like a I don't know, like French sliding doors where it's glass, head to foot.
But in that case, the radar is detecting its reflection of its own signal. It seems like in this case, they're scanning for somebody else's signal.
Yeah. But I guess radars are, I guess, because of the frequencies that they work at, I guess they can detect, bodies really easy. But yeah, that may not apply in this case. But anyway, saw that, and I don't know if that piques Murray's interest or not. But
Well, the one thing I was quite unclear about is, to me, it's a distance measurement, not a direction. So you get a distance from the anchor point. So the anchor point is a source of information, and you get a distance, like a time of flight, from that unidirectionally. And I think the only way that you can use this to get an XY coordinate, like a two-dimensional position, would be to use two of them. And that's the only way.
Two anchors. Yes.
No, I mean two. I don't know that this particular board can do two anchor points. You might have to have two boards, or do you think? Because
actually, yeah, I think you need. Well, they show it with two anchor. The board. I guess you can configure it as an anchor or a rover, and they show it with two anchors. So I think there's got to be a way to distinguish, which one you're getting information from. So, and it looked like they were doing triangulation.
Did you guys see the reply from Jesse Brockman in the email? In fact, if I remember right, and he did a presentation to the club on some Saturday much earlier this year. He talked about positioning, among other things, I think, or maybe it was last year, but he's used this DecaWave based technology in the past.
Oh, he did.
Yeah. I forget where it is, but I'm wanting to say that if we went back and if you went back and looked in the DPRG clips, you might be able to find his presentation on that, or just email him and ask him questions, because I distinctly remember that he said so in the email chain that he's used it before. Maybe not this specific implementation of the DecaWave, but
yeah.
He did say his experience was that the placement of the anchors was difficult or critical. I can't remember how he phrased it.
Okay. Anyway, yeah, I saw that, and I have my little cute demo board to show. This is for the it's Seed Studio, and this particular one, it's for the Cutie Pie or Seed Studios. I think it's XAIO. I'm not certain how you pronounce that. Zio. I don't know. anyway, so it's got an OLED display. It's got, and this is Grove based, which is kind of a pain because the Cutie Pie is quick. It's got a little quick connector on it right there. But two, I2C connectors, one UART and one either digital output or analog input pin. It's got a real-time clock, does battery charging. It's got a SD card slot on the back and a battery holder for the real-time clock if you want to put one in. But kind of just an expansion board for the Cutie Pie. One of the other sensors that I got for it is I think these are based. It's actually I don't know if it says it in there or not. Yeah, the AS5600. It's one of those still in the bag there. Basically, it's a magnetic encoder, and so you just have to put a single pole magnet, not one of Palulu's magnets, but on the end of a shaft. And I think powered up in like a standard configuration gives you 127 counts per revolution, 128 counts, I guess. And then you can get much higher resolution out of it if you want. I think all the way up to, I want to say like 4,096 counts per revolution. And those were only $5, and they actually came with a Grove connector. That board does not come with any Grove connectors. So if you want extra Grove connectors, you have to buy them. So I looked in the box after the discussion about the other board to see, but no Grove connectors. So,
but, Ray,
yeah.
Is that an AS5600?
Yes, it is. Oh, wait a minute. Yes, AS5600.
I have a couple of those. I've been meaning to try them, but haven't got around to it.
Yeah, I tried. There was another form factor. It came from the manufacturer. This is Seed Studios design, not anywhere close to what the original manufacturer did. But they didn't include any magnets in this, and the manufacturer did. You would think they would do that. I don't know that you can use any magnet.
I bought them from AliExpress, and it came with a magnet. The one I bought, it was a little white square circuit board.
Oh,
and it came with a magnet. And from what I'm reading, the magnets need to have the north and south pole on the edge.
Oh, on the edge, not in the.
As opposed to the flat surface.
Yeah, I don't see any magnet in here, but I did get.
They're really small, Ray. They're really small.
Yeah, very small.
So I can't claim that my Chinese pronunciation is that good, but the Seed Studio board called XIAOU or whatever is actually the Chinese for small. It's xiao, and it just means small in Chinese.
Anyway, the little speck there is the magnet that came from the manufacturer right there.
So how does that work? How do you get 127 counts with just one magnet?
I think it's like from what I remember, it's like a multi-Hall effect sensor, and it can actually determine when that magnetic field is rotated, even though it's,
Even if you turn it on and it's near the magnet, it'll remember wherever it was.
So
yeah, that too.
So it's basically it's able to deduce not just a pulse when the magnet swings by, but the actual direction of the field.
Yeah, it's an I2C or SPI device.
Yeah,
Yeah,
I'm
these are
curious.
definitely
I'm
IQ
curious about the
cord C.
physics.
Dave, it's considered called an absolute encoder. Otherwise it's really meant to know what direction you're facing in. It's not really meant to be I'm rotating. It can do that, but its real purpose is to say I'm at 123.5 degrees or something like that. I can't remember what the resolution is. I thought it was higher than 127. No, I think it's
4096.
Huh? 4096. Yeah, that sounds more like what I would have thought.
Yeah, the max resolution is. I think it just, if you don't, configure it anyway, its default is like 127 counts per revolution. But if you want higher, it's just a matter of,
But like I say, its goal is to be an absolute position. Otherwise, so if you put this on a wheel and you turn the wheel a half a turn, it would know that you turned it 180 degrees.
Mm-hmm.
And it would know that it was at 180 degrees.
Does it do that?
Not just that you turned it 180 degrees, but you now left it at 180 degrees.
And it does that by, in some way,
It's a Hall effect sensor, but I don't know.
The Hall effect is returning like a value that corresponds to the direction of that north-south magnetic field in relationship to the Hall effect.
I think that's correct.
So like when it's, say, perpendicular, you get a big voltage, and when it's horizontal, you get a small one or something.
I don't know exactly.
It's a digital signal. It's
you get
an I2C.
Well, that's after it's transduced. I'm actually asking about the physics of how that signal is produced.
I don't know. It's in a little black chip on the board. Don't let the smoke out.
That's right. The secret is in the smoke. From what I understood, it was like a small array of Hall effect cells, and somehow it could distinguish, or you got a different response out of the array of cells based on which way the magnetic field was pointing.
So more than one Hall effect cell.
From what I understood, yes.
Yeah.
Okay.
Don't quote me on that though. I haven't read it.
It's in the package too. So I mean, it looks just like an IC, a little flat pack IC.
Yeah. Yeah.
And you just hold the magnet on top of it if you rotate it.
Cool.
Right.
And there's probably what is the distance, Ray? How far does it have to be from the package?
I think it's a couple millimeters at the most. But it probably depends on what magnet you're using.
Yeah.
I think it might not even be a couple millimeters. I haven't actually read that in a while, so I don't know. But yeah, high resolution 12 bits.
I'd be curious to see how much out of center can your magnet be?
I know it can handle, it being like eccentric or off center and still work. I don't have it's probably on the website of the manufacturer of the chip. It doesn't, this is a very small sheet. It really doesn't tell you that much.
It goes with the small part.
Yeah. Yeah.
Ray, did you put a link to that in the chat?
Yeah,
I can't. Oh, well, I don't know if the chat's working for me today.
Yeah,
Well, that's
it
fine.
was. It's also been put in the chat a couple weeks ago. I think we talked about.
Oh,
this.
yeah, I think so. Yeah.
How much details do you want? I've got a data sheet on it here.
Okay. How far can the magnet be away from the chip?
I'll let you find that out.
Oh, come on now.
I've looked for it and I couldn't find it.
No, I'm sure that's in there. I'm sure they got it on the top
Hey, if you
somewhere.
paste the links in there, thank you, Pat, and then we can get
Thank
the
you,
crowd to
Pat.
work on it.
Yeah.
I've been looking to see how far away does the magnet need to be? Can I mount the magnet on a piece of steel? And can it be slightly off center? What happens if it's a 32nd of an inch off center?
Yeah, I thought it was fairly tolerant of that, so it it didn't have to be perfectly concentric, and
So my thinking with this is, and it may be the secret answer to my 50 kilogram servo or 150 kilogram servo.
Oh, as far as positioning accuracy?
Yeah, being, you want to move your truck to 30 degrees, you hook one of these things up and
Oh yeah,
let the hydraulics go, or let a large, like a wiper motor, turn it into a servo.
yeah. I was kind of concerned. I thought you could set it on the shaft of the motor, um, but they don't tell you to try to magnetically isolate the magnet, fields from the magnet and the motor shaft, and you think there might be some interaction there too because it's a motor,
It does have some magnets swinging around inside of it,
Yeah, if you look at the
or
link
these magnetic fields.
if you look at that link that Pat shows, and you
Mhm.
slide down a little bit, they have related boards. I guess these are their application boards, and they have one where they can show you can see the magnet mounted on a knob, and it's got a little plexiglass holder that's holding it above the board. So I mean, that's probably a typical use. Let's see. Okay.
So the magnet's isolated from the motor shaft with a piece of plexiglass. Is that what you're saying?
No. It's held above the board by a little, if you think of it as a U-piece, a U-shaped piece of plexiglass.
Oh, okay.
Yeah, they also looks like they have they have one that looks like it may be made to be an encoder specifically. And I think that's called the AS5600L, if I'm looking at it right.
Where do you see that?
On the link that Pat put on,
No, I'm on the web page. I don't see that particular.
slide down. Okay, you see where it says you're on features and benefits?
Features. I'm on related products, I thought.
Doug, maybe you could share
Okay,
your screen. We could see what you're seeing.
Yeah,
There
I
you
can
go.
see the link.
There you go.
See, sure.
Okay, I got a better document here. I'm going to paste the link in.
How do I do that?
So I've used these chips before. You can mount them right on the motor shaft. It's not a problem. I looked in the data sheet and found that typical air gap is between 0.5 millimeters and 3 millimeters.
Okay, yeah. Okay.
And it depends on the selected magnet.
Okay, that sounds like the answer. What, 5 up to 5 millimeters?
3 millimeters.
3 millimeters.
Yeah.
I mean, it depends on the magnet. They're saying a larger and stronger magnet allows a larger air gap.
Here's the one I was showing that they have as a little U-shaped. And this is somewhere they actually had a picture of it. Maybe if I go down here and click on this.
And I think as somebody mentioned before, this chip is not really the best chip to use for getting in quadrature encoding,
right?
Because it's strictly a positional sensor.
Yeah.
But there are other versions of that sensor family that have quadrature outputs, as well as reading the position if you really want that.
Yeah, that's what I think this one is. Oh, wait a minute. Where did they? Here's a rotary sensor here.
Oh, the 5030, yeah. This looks like it's the 5600.
Yeah, they have a wide range of them with different capabilities.
Yeah. Let's see, it's a digital angle interface per PWM. Well, that's not quite what we want.
Yeah, this one's got an I2C output or an analog out PW, for PWM,
Mm-hmm.
and the maximum resolution is 4,096 pulses per revolution.
Yeah, but the idea of an absolute angle sensor is kind of cool.
Mm-hmm.
Many high-end servos use these sensors for their position sensor.
Mm-hmm.
There's also a Chinese knockoff, I think, that's cheaper, but it's basically the same thing, same technology.
Mm-hmm. Yep.
Anyway, that's all I have.
Cool. Very good. Thanks.
Yeah, the other link I put in is the complete data sheet on it.
Cool. Right there in chat.
Yeah, on my version of the data sheet, page 33 talks about the magnet.
Yeah, page 30 shows the orientation of the magnet on the data sheet that I linked.
I just love how these little bitty devices have a page 30.
That's right.
Yeah, we live in the age where the size of the devices doesn't determine its complexity.
Yeah, and let's not even talk about the data sheets for the stupid little ARM, simple little processor, right? 360 pages later.
Back from antiquity, I remember one of the people from Sperry said that when the weight of the documentation exceeds the weight of the aircraft will not fly.
That sounds like somebody that doesn't want to document anything.
I don't know. I can't remember the number, but the documentation for a 747 is mind-boggling.
Is that why the documentation for the Boeing 777 MAX 8 or whatever it was, or 737 MAX 8?
737.
Yeah. Is that why the documentation was only 10 pages? Make sure
Actually, that's a good point. I actually, Carl, just to sound a contrary note, I actually love all that ARM documentation.
Oh, I do. I wasn't speaking.
The more the better. And the fact that you have, a nested vectored interrupt controller and a direct memory access controller and all this stuff in a chip that'll fit on your little fingernail.
Oh yeah.
Those are things I learned in the presence of big dog computers, and to see that available on something that it's just astounding to me.
Where you can fit 2 or 3 of those on your fingernail. Yeah, that's.
I had the manuals for an HC12, Motorola HC12 processor. And so I sent away for the manuals because I wanted to get some of the clock functions for the timing and clock functions. And they sent me a box full of books that had piled a foot high. No. Had like 20 manuals, more than like a half-inch thick.
That STM32 board I was looking at last week, the 157 or whatever, that has both an MCU and a single board computer on the same board with 2 ARM chips on it.
Pretty overwhelming.
What's that?
Pretty overwhelming.
I'm really tempted just to own one to try it out, because I haven't done any of that stuff with the Cube programmer and all that, and it would be like diving into like the biggest deep end, I think, on that board.
Well, Pat, all you really need is the opcodes and then a push button panel where you can fat finger those in. What other documentation do you need?
Yeah, I built a Z80 years ago, like you say, with push buttons and punching in codes into EPROMs by hand.
Pretty wild. At least it wasn't with toggle switches.
Actually, my first. Oh, go ahead, Pat.
That's what I had. That's what I had built.
That was
a set of toggle switches to address the EPROM with the data bit, and I cycled through them enough to get a bootloader going on it to bring up a prompt.
Exactly. You get up to that stage.
Long time to get that EPROM programmed.
You get up to that stage, you can read a paper tape, or God forbid, a cassette tape.
Yeah.
Shades of BDP8.
Yeah, my first robot was actually a Z80 single board computer in 1979, and it was hex keypad and LEDs. So I was actually already advanced.
And we were glad to have it too.
Yeah, it's a pretty amazing board, actually.
Oh yeah.
I still remember the PDP-11 having to set the address switches on the front of it and give it a reset signal so it knew what address to go read the disk drive out of the BIOS.
You guys are
But you
aware.
know what?
You guys are
You
aware.
could
that-
watch.
Oh, go ahead, David.
You could watch those flashing LEDs and tell what the system was doing. You could
I was
tell
going
if it
to add that
hung.
for $260 American, you can now buy a PDP-11 desktop computer.
Simulator.
It's a simulator that runs on a Raspberry Pi, but it actually runs, I think, 5 of the different OSs that could run on a PDP-11, and you can buy it for like, I really want that too, but I have no use for it. But it's actually got all the switches and the LEDs and everything. It's exactly like one.
Now look,
Is that by Steve Gibson? Is that by Steve Gibson?
I don't know, but it's got purple and red switches.
this is the Dallas Personal Robotics Group. If we only bought things that had that we had a use for, we'd go out of business.
Yeah, well, I look at that thing and I would love to have one. It's beautiful, actually. They did a really nice job of it. It looks exactly like a little tiny version of the PDP-11. It's really nice.
I remember seeing a guy, they had replaced a room, a VAX, an 11780 VAX in a room. There's a huge, like 20 by 20 or 30 by 30 room with super cooling and everything else to keep this thing running. And they replaced it. They gutted it on it was a 2-week shutdown. They gutted the room and they put a little folding table in the middle of the room. And they put a little cube box about 16 by 16 by 16 that replaced that whole VAX.
Yeah. Well,
I have a sadder story. When I first went to SMU 30 years ago, they were retiring their VAX. So it was in a data center, an elevated floor, cooling, and it had 4 or 5 disk drives that are the size of a washing machine and hold a 300 meg pack. And so Nancy Cunningham in charge of getting rid of that, and she's calling around trying to find somebody that would buy it, and nobody would buy it. Finally, she found a guy who offered her $600. And, you know, there's $600 worth of casters on those things. So she laughed and said no, but eventually she went back to him with her hat in hand and said, okay, we'll take your $600. And he said, no, I've thought about it. I don't want to do it. So we got a hold of Ron Doer, downtown Dallas, if any of y'all remember Ron Doer. And we paid them to come take it away. That was the end of the story. We paid them to I don't know how much she paid them, but
those washing machines made a heck of a noise too. They were thrilling to just stand next to.
All I remember is my first summer job at Carnegie Mellon. I went to the data center and there was this room filled with DEC 20s. They were about the same vintage as the VAXs, and they were about shoulder high. So I would go and do like hand presses on them and stuff. So, but then I noticed that, there seems to be this air going in at the top. So I don't know what came over me, but I went and got a whole bunch of printer paper, like copier paper, 8.5 by 11. And I just held it up and it held it up to the top. So I got another piece. So I did this down the whole roll of DEC 20s, and Pat's laughing and Murray, because I think they can imagine what happened next. About 10 minutes later, I'm back, having a soda or something, and the phone starts ringing. It's like, the computer stopped running because I shut off the air supply. It overheated.
Yeah. What were you thinking?
That was before the YJE stage at the Texas Instruments, being young jerk engineer. So that was even before then.
also, Carl, I think the plural is not vaxes, it's vaccine.
Vaccine?
I thought that was a herd of young women.
Sometimes they're confused.
Very nice.
I have another update.
Already? That's cool. What progress?
Already. So I did some testing because somebody said, I think it was with was it Doug or David? David A?
Yeah.
Somebody said, did you put a tester on it? On my my Pololu sensor.
That sounds like Mr. Parody.
Yeah, I
Maybe
think so.
Mr. Parody?
Use your own meter, I think he said, right?
Yeah, use my own meter. Well, I didn't catch who it was, but I did do it, and I don't know if it's the sensor. I think it's my homemade cable.
Oh,
What was
Hooray!
working? What was working good? I don't have continuity on my clock line.
That sounds like the best possible answer.
Absolutely. Hallelujah.
What's that?
Eureka.
The best possible answer.
Yeah, usually it's the easiest, and it saves me
Also-
$35. So
Also, calm and power. All your problems really are calm and power problems.
when in doubt, ground the crap out of it.
All righty. Okay, so we had everyone in the list so far except Kareem was on kind of a maybe if the team was ready to go, and there have been some other folks coming in since then. So what do you think, Kareem? Does the crew want to jump on?
I think we're probably going to pass. I'm not sure. Trey seems to be on as well remotely, so he might have an update. But here's the robots. It's like in pieces. Oh, and speaking of continuity, we got this slip ring right here that just got soldered together. So we're wondering whether or not that was an adequate job.
Doubting my soldering skills.
Shall we start a betting pool? So we don't really have a proper update. You know, they're working furiously, but right now the robots in between transitions. So yeah.
It's in transition. All right.
It's in transition. Yeah. You did see that it's like the second slide is on there, so it's like very long bot now. Yeah, I don't know where the control is for it. It just turns it on and off. Probably got to hold it. Anyhow, they're working on code and changing the electronics around to accommodate the changing length and things like that. So they got a ways to go.
Yeah.
Trey, do you want to say anything? Are you still on there?
Not seeing him. But
You dropped off.
so
Okay.
you have like 4 days for the next target? Plenty of time, right?
Well, they've got to have their portfolio turned in by tomorrow night, and then judging's Thursday and Friday, and then they've got a Saturday tournament. So we'll see.
Okay, we don't get a gold star if it's not running, but I think we should have something like a red star that says, yes, but we're working really hard.
They are doing that. Yeah. They're all over the place. All right, we'll take a red star.
We get it. Yep. Awesome. Oh, best of luck.
That's it, bro.
They'll pull it off. We'll see.
We will see. Oh, the other night when they were having troubles, one of the things that was wrong was one of the wheel motors was completely dead. Came out of the box that way, and we didn't test it before putting it on the robot. So that was one of the deals. And we did start driving it around. So they drove it around with two different drivers controlling different ends of the robot, and remarkably, it didn't fall over that much.
That much.
That much.
Yeah, that much. Love the
Yeah.
that much.
No, they really had to push it to do that. They discovered ways that when you make it as short as possible and then you do a rapid stop, it'll do a wheelie, and sometimes it'll flip over its front end.
Handlebar. Excellent.
Handlebar, exactly.
Yeah.
So in other words, it's got some juice behind it, and it can it's probably faster than they can safely control it, so they'll probably slow it down in software.
It's one of those, what could possibly happen?
Yeah, exactly. It could be entertaining, and that's what we're really shooting for. So
It sounds like it's accomplished that already, so you're doing well.
People were mentioning discs, and I was thinking back about the old Ramax, and I came up with a copy of it. Yeah, there we go. There's a picture of it. There's the discs, and they were only $10,000 per megabyte.
That's a fancy looking one.
Yeah, they were huge. They were refrigerator sized.
Yeah, back in '84, I worked for E-Systems, and we had a hard drive in one of our equipments that was 100 pounds per. No, I'm sorry, a pound per megabyte. It was a 100 megabyte drive, and it weighed about 100 pounds. 19-inch rack mount.
All right, we see Paul has raised his hand. So what's up, Paul?
If we're running low on topics, I have a. Am I the only one who didn't know this kind of topic?
Oh, jump in, please, because we were out of queued people. I was about to ask if you or I think Harold came in, or John K, or James, or Ed.
So-
I think those are the only ones we haven't heard from yet. So jump right
So
in.
I was looking at ways. If you want to power your robot while it's like on the bench or on the floor beside you, and it'll be sitting for several hours, you don't want to leave it on battery. You'd like to run it off of a charger or something. But in the case of my mower, it pulls too much current when I start the blades, and it'll brown out the power supply. And so ideally, you'd like shore power to feed into the electronics, but you'd like the battery. But you don't really want to connect the charger and leave it connected to the batteries, because it'll overcharge LiPos, and LiPos get very unhappy when they get overcharged. So ideally, you'd like a diode between the battery and the shore power connection, so that the battery provides backup oomph if the shore power can't supply the current demand of the robot, but yet the shore power doesn't charge the batteries when they're already fully charged. So he was searching around for solutions to this, and I came across something called the ideal diode. Am I the only one who never heard of an ideal diode before?
So I haven't heard what.
I think it's just a diode that has really good characteristics.
Are you talking about the one that uses a FET as a diode?
Exactly. I'd
Yes.
never come across that before, because a diode has like a 0.7 volt drop across it, which if you got a robot that's drawing 20 amps, you're going to be dissipating 1.5 watts in the actually 14 watts in the diode, be overheating like crazy. And so there's a circuit that I was like so amazed that I'd never in all these years run across this before.
In synchronous switching power supplies, the voltage drop across a FET, the VDS is much less than any diode. So it is, they'll use those in, to try to get the greatest efficiency out of the power supply, because you're right, if it's dissipating that much power, it's not going to be very efficient.
Yeah.
You'll also see them a lot in polo loop modules. If you look at the circuit of a polo loop module, it'll be the reverse voltage protection. Will be a FET.
Yeah, and the Maker PI RP2040 that I was showing uses 3 of those to switch between the 3 different supply sources.
So are you on 2 pins of the FET? I don't understand.
So I'm trying to share my screen, but I'm having difficulty. Apparently, I need to grant permissions to something.
No, okay.
Well, I think that's local to your box because we don't need to
Yeah,
give
yeah,
people.
yeah, yeah. It is. I ran into this before. Give me a minute, and I will share something. I got to figure out how I did it before to turn on sharing.
Have you tried going to the Present Now box and clicking on that, and then clicking on just share your entire screen? That's all you should really have to do.
The which box?
It's a box with an arrow pointing up in it on the bottom of your screen.
Right. Yeah. I've done that, and when I do that, it
Yeah.
says, "Can't share your screen. You must grant permissions in order to screen share." And I did this once before, and apparently it didn't stick.
Oh.
What happens when you click on the picture of the screen? Just click on the picture of the screen. Anything?
I don't understand picture of the screen.
Well, okay.
Oh, yeah. That's what I said. It gives me a dialogue saying, present a choice of your entire screen or a window. And if I select a window, or if I select the entire screen, it says I can't share my screen. So sorry, guys. I thought this would stick from when I solved it last time. Let me just go in a small hole and search for the solution again.
That's okay. I can't put anything in the chat, so I don't know what's going on with that.
Having a rough night with me.
Yeah.
Oh, yeah. I found it. That's right. There's a icon next to the URL that controls whether you can share your screen or not.
Huh.
So like if you just have a regular NPN transistor and you can use the base and the emitter like a diode by just ignoring the third lead, is that what we're talking about doing? I don't see how that would work with an FET.
No, it requires a controller. I can put a link. TI, amongst a lot of others, make ideal diode controllers. Some of them have the FET built in if you're not drawing too much power, but otherwise, there are different ones that you can use an external FET.
Right. If you use an external FET, tie the gate to ground, and tie the two, source and the drain for what you want.
Yeah. So here's the circuit, and you need VBE to be matched. So they typically use a two transistors inside a single package, matched transistors, and the FET is the thing that acts as the diode. And let me think how this circuit works. In the forward direction, so that this is how the direction of the diode, and so it will have a nearly zero forward voltage drop. So it's milliohms of forward voltage, of forward resistance, but a high reverse resistance. And the way it works is if the output or the anode of the circuit, anode equivalent of the circuit, becomes lower than the cathode equivalent. This is the left side is the anode, isn't it?
Right.
I'm sorry, the cathode becomes lower than the anode. Then initially current flows through the forward biased body diode of the FET, which then flows down through this transistor, and The transistor is turned on because this resistor is grounding its base. So, so the transistor port turns on, that pulls this point high. I'm sorry, it pulls it
Low.
low,
Yeah, channel.
which turns the FET on. So you get the FET then gets turned on by its gate, which means you have a forward resistance of milliohms instead of the 0.7 volts that you would normally expect from something like a silicon diode or 0.25 volts from a Schottky diode.
And so these two transistors and the two resistors associated with them are what I'm sorry, James was describing as the controller.
Yes.
It's on
And
the little graphic representation if anyone cares to see it.
yeah, and yeah, let me, I'll stop sharing here in just a sec, but let me share this. Amazon, for example, they're apparently used a lot in solar panel circuits. And so here's like one for like $7, 15 amps, ideal diode, will have almost zero voltage drop in the forward direction, but be completely blocking in the reverse direction. So it's like really cool, really a cool circuit.
Cool.
Let me unshare so that I can figure out how to do that. Here we go.
In that circuit I was showing before, yeah, there we go. Hear that? Yeah, there's the circuit right there where it brings the 3 voltages in and 1 out. There's the 1, 2, 3 inputs and the output. And you see it's using the MOSFETs there to control voltage, or actually act as zero resistance switches. So
Where's the ideal diode? I don't see it in there.
that's it, right there.
The FET.
Upper right.
These right here.
Oh.
Those,
Oh,
those-
yeah. Okay, interesting.
And effectively, depending upon the voltage that's applied to these 3 pins, whichever is the highest is the one that gets pulled to the output.
Yeah. That's another use of that is for power sharing between different not sharing, but power selection between different sources.
Yep. So anyhow.
Anyway, I was like, ran across that a few weeks ago, and I was like, wow, I never ran across that before, and it's like, that's so cool.
Yes, it is.
Doesn't Palulu sell some ideal diodes? Maybe not, but I thought they did.
There's tons of them on Amazon at pretty decent currents, almost no money, and
pretty good specs
and high current.
Mm-hmm.
I didn't realize they were so readily available as little breakout boards. That's very convenient.
Yeah.
Thank you, Paul.
Yeah. It was like an insight. I was like, wow, I can't believe I never came across that circuit in all these many long years.
Can you paste the link to that Amazon site for that diode?
Yeah.
They have varying stock. Here's one on Amazon for 50 amps, but they want $22. But on Prime, it could be delivered here like tonight.
Next day shipping in Canada is 3 days from now.
Yeah. Time is relative.
Thanks, Paul.
Well, cool. That was a good update. All right, so swinging around. Who else would have anything that they want to share or show?
I got something. Am
Go
I
ahead.
up?
Yeah, go ahead. And Murray's found a PDP-11.
They're out of stock.
Go for it.
I'm going to start a side project for next Halloween, and it's going to be, if I can pull it up here,
Fly.
this thing. The guys made the parts available for 3D printing. I've already printed all the parts.
Even if the quality of the prints is not quite up to standard. So all the components are really simple.
All right, so I just wanted to show the animated part briefly, but yeah, I've already 3D printed all the parts for it. It's not just rebuild the movable eyes, but I'm going to take a Raspberry Pi 4, run OpenCV on it, have it do face detection. So I'm going to integrate the two, where one shows you basically point the eyes wherever the face is. So as somebody walks up to your door at Halloween, the eyes follow them. So
You can put that inside your spider.
well,
oh yeah,
it wouldn't be realistic. A spider with eyes that big. Actually, I was thinking of finding a model
Realistic
of a skull.
spider, 6-foot spider.
You know, no matter what you put that in, that's not going to be creepy at all. It's not creepy in the least.
Well, I wanted to find a 3D printed skull that I could fit into, but the mechanism is kind of bulky for that. I'm probably not going to be able to find a skull I can fit it into unless I modify the base of it. But we'll see.
Yeah, don't spiders have like 6 or 8 eyes? They look bizarre.
Bunches, yeah. Depending on the spider.
Mm-hmm.
And they're usually blue eyes, I think.
Never got that close.
The thing is about that guy's project, I watched the video. My artistic skills are not as great as his. The way he made those realistic looking eyeballs, he got some paint in there and some acrylic and some sanding, and it's like, I watched that and going, that's going to be real challenging to reproduce. So I'm just going to put a simple, black dot there and say, okay, that's the center of the eye.
Yeah, we have a lot of snakes out here, and we looked up, how do I try to identify them? And one of the descriptions was if you look at the pupil of the snake's eye, if it's venomous, it's like a certain shape, and if it's not, it's another shape. Of course, a snake's eye is like this big, and I'm sure that if you got that close to it, he'd bite you. So it's like, yeah, that's really useful.
that's cool. So Murray, you were showing the latest Tindy find.
Yeah, that's the link to the project. I was on his mailing list, and he, I think about 3 or 4 months ago, announced that they had some available. They sold 3,000 of those last year.
Oh.
So he's now out of stock again, and I just put myself on the mailing list so I could buy another useless object to put in my house. But if you look at it, they're really quite beautiful. They did a really nice job with the plastic switches, and it looks, just like a small version of a PDP-11. And like I said, it runs in the simulator, I think 5 or 6 of the OSs. So you can run a full-on 1970s Unix on that thing.
Was there ever a PDP?
And what I like is, I like this image because, at a glance, it looks like the right kind of terminal. And you think, wait a second, ThinkPad? What? That's kind of beautiful in a way.
Yeah, and it's actually got a real wood base. It's quite nice.
Electronics should have a wood base. Exactly.
Yeah.
Yeah.
But look at that, it's beautiful looking. I mean, that's just gorgeous.
With 60s and 70s era switches. Absolutely.
Was there ever a PDP-8?
Yes. Yeah.
Number 8.
Yeah, they used to have one in the Des Moines Science Center. Paper tape.
I like this great picture with the old keyboard too.
Oh yeah, yeah.
Oh, it's a fourth one over. Look at the size of those.
The only thing I can say is I don't know that I could actually go back to, like I think it was Pat or someone was saying, actually entering the address and the data and then sending save. And it's just, oh my God, that was so incredibly tedious.
And then when you're all done, you show your friends, watch, I can run this memory test.
Exactly.
And look, I can move it over here to another part of memory so I can test the part of memory it was in.
Oh, yeah. And just,
Okay.
just loading the bootloader took hours. I mean, God.
So given this discussion, I have to ask if anybody is at all interested in a Heathkit VT52, let me know, because there's one in my parents' house that I need to find a home for.
That's all right.
It has a detachable keyboard.
IBM convertible. That's the kind that had two floppies, and it was their first luggable.
I remember that, the old days, the lap crushers.
Yeah.
Yeah, it looked like a portable sewing machine.
Yep. Yep. And you had modules you could plug in the back, including a printer.
Little 4 or 5 inch screen on the front of it.
That's right.
I was just looking around here because at one time I could still lay my hand on a box of 8-inch floppies, but they must have gone down the way of some cleanup.
You turn your back and those things disappear.
I remember
back when they were actually floppy. Remember how floppy those things were?
5 1/4 inch floppy was 360K. There was nothing I could do to fill that floppy up.
I've got a 5 1/4 inch floppy that I have no hardware to read it on, and I really wish I knew what was on it.
Dave is off digging for something. I think he's looking for a floppy.
It could happen.
I think I got Arduino programs that are bigger than 360K.
Well, the company I work for went under, more than one actually, but this particular one allowed us to buy up a bunch of their, I got a real nice workbench and some stuff like that. And I walked off with a dual 8-inch floppy reader in the box, never been used. And I kept it in the box, always thinking I would find some project worthy of it, but I never did. It's still in the box, brand new.
Anchoring your house down in case of tornado.
You should contact Radwell in the US. See if they're interested in buying it from you.
Oh, I kind of gotten fond of it over the years.
What do they use it for?
Like I know of one mill that is still running a lathe veneer line, and some of their speed control is done in a PDP-11.
You know, all that hardware was real hard to make back then, and so it's really beautiful. You know, nowadays we can do it so cheap, you just slap it together and it works. But just mechanically, it's a thing of beauty, kind of like a teletype.
You were saying earlier, what was it? 1 pound per meg. So, how much would my terabyte SSD weigh?
Hey, look what Dave's got.
Oh, geez.
Oh, is that one of the retro computers? Yeah.
Oh, those use modern floppies, though.
Yeah, it's got 3.5 inch floppies on it.
They weren't even floppy by the time we got to that.
Those look like Captain Kirk with the little colored cards he put in the computer.
Yep. IBM convertible PC.
Man, portable PC. There you go.
Dave, does it still boot?
Yeah, it will still boot.
Is that a 286?
Which?
A 286 or a? It was
I'm not sure.
I think it was the the huge thing with the 386 was we got a flat memory space.
Yeah.
And that changed the whole world.
I think it was a 186.
Might have even been just an 86.
Might have been just an 86. Yeah.
Yeah.
And it had multiple memory modules so that you could get up to the 64K.
Well, you know, Dave, how things go these days. You hang on to that, it'll be worth a fortune.
Yeah. Maybe so. But you
Okay.
in the back, where the modules would plug in.
All those parallel connectors.
Yep.
Yeah, printer port. That was, I guess, the first thing to go, right?
Yeah.
No, that turned into our game controller port, and that's where MIDI came from. I mean, heck, it was the only port we had.
Yeah.
Oh, they didn't have RS-232 ports on the back.
That was later.
Oh, it was.
That whole connectivity thing was a kind of a afterthought.
It was a mess. And then even the Ethernet, remember the coax for the Ethernet?
Oh, yeah.
Having to terminate lines, you could only have so many on a, I mean, subnets were literally subnets because it was a big long coax with a bunch of taps on it.
We still have those running all over in the ceiling in the building that I work in, abandoned, but nobody wants to roll it all up. What would you do with it?
Just need some good copper thieves. They'll have a way to find a use for it.
I tried to pull out some of it one time, but it's annoyingly, somebody went through and put cable ties everywhere.
So there was, okay, so a few startups ago, well, I say startup, but it was, anyhow, it was a big company, but they built a data center over in Richardson, and it was the ground, it was the network control center for, and the server center for a company that had a large commercial satellite and a ground station, and I was on the team that did the mobile phone. So on a good day, the mobile phone would talk to like AT&T's towers. On a bad day, you could push a button, and the mobile phone from your hand would talk directly to this geostationary satellite 22,000 miles away, and the signals would come up and down through this ground station in French Guiana or somewhere and go through this data center over in Richardson. So you go walk in a data center in Richardson, and you know, it's a fairly big room. I don't know how many square feet, but it was a big room. There was a lot of racks of way too big telecom equipment in there, and all the cabling wasn't cable ties. It was lashing cord with knotted cord.
Those are beautiful. Those are just beautiful. Yeah.
Wax lacing cord. Yeah, that's what.
Yeah.
And you know, for a startup, they wanted to make this as their showcase, so they didn't want it to have some cheesy cable ties because those would always get like over tightened or something. They had some crazy excuse. They paid like 3 times more than they needed to, so that some poor soul could go in there and like lacing cord every few inches. It's like, I hadn't seen that since it, in a defense world, we would make wiring harness, or the people in the line would make wiring harnesses for aircraft.
Yeah.
And the mill specs would say, okay, thou shalt have the lacing cord every 1.25 inches, plus or minus an 1/8 or a 1/16 of an inch. And,
yeah.
And sure enough, the inspectors would go in and measure it. And if it was off, they'd reject the whole thing, right? So, but to do that for a data center, anyhow, you could call it craft, I suppose, but it just seemed like overkill. Okay, so I think we're just rambling all over the place, and that's fine. But does someone else have some other topics to bring into this ramble?
If nobody else has got anything, I want to get my gold star I got this thing powered up enough to go.
Wait, I thought that was your nachos.
I did do nachos.
Oh. That's a gold star for nachos?
This is what's left of the nachos.
Oh.
Let me see if I can get over to the, I guess I should, let me pick this up again for a minute. Get over to the screen so that I can share. Now I've got my viewer up. So hopefully the computer is looking at the robot, and I can
Yes.
and then click on. Yay, it works.
Telepresence, driving it around.
So
Doug, I have spent so much time on my hands and knees working with my robots.
that's right. On the plus side, let me stop presenting here. It actually worked. On the minus side, it's not doing anything I didn't show 3 months ago. It's just that it's back to working again.
But you know, how
They'll
many
give it when
robots
you
can you
go
turn on 3 months later and they'll still work? So that's
Yeah.
Okay, gold star.
Oh, thank you.
My wife had made a bunch of bags of cookies for Christmas presents, and she sealed them up with these little gold stars on a little kind of baby clothespin. And so I've got one here right next to my computer in case I ever need it. I figured I would clip it onto my shirt like that. And I recommend everybody get one. So Doug, this one's for you.
There you go.
There's a shopping mall near my house. Well, it's about 25 minutes away. And it's kind of one of those sad shopping malls that you don't really like to go to, but it's the nearest one. And I was walking outdoors into the area that's even sadder than the rest of the sad mall. And there was these two really heavy people walking in front of me. And the woman was carrying this gold star. It was about this big and it was about that tall. It was like a three-dimensional gold star completely covered in glitter and gold foil with little streamers coming off. And I had such a desire to ask her where she got it.
Well, I thought you were going to tell us you knocked her down and ran off with
That's
it.
right. I took her gold star.
Well, you guys don't, I don't, anyone's been to New Zealand, but there's these sort of dollar stores that are tailored to the Pacifica community, and they sell stuff that I have no idea why I would even go in there. It's just like, you know, they got these flowing robes with covered in flowers and plastic flowers and all this stuff. And there's about 4 of those stores in the sad outdoor mall. So I've never been in there into any of these stores, but I'm sure that in those stores somewhere is this huge gold star. It would be almost like the challenge just to find the beautiful giant gold star. David, I was thinking of you when I saw that, though. It's time to buy one of those things. She looked really happy. She was walking along with this thing. I don't know. Maybe it was a birthday present or something. I don't know.
I guess maybe a Maori tradition store.
It's probably more. It could be Maori, but it's more likely Samoan. And
Oh, Samoan. Okay.
yeah,
Maybe
Maori,
she won it at a robot competition.
yeah, Maori really don't do the flowered dresses. Like, you know, I don't know what they're called, but they're like a muumuu or whatever. Like
Mumu. Yeah. Yep.
And that's typically more like Tongan or Samoan. But you know, those this riotous color, you know.
If we were all meeting together, we could pass out gold stars. But in the absence of that, I just think we're all going to have to make our own and then wear it on the honor system.
Ah.
Or if Zoom allows you to create custom emojis, you can make a gold star emoji.
Oh, that's a great idea. John, are you volunteering?
I don't know if Amazon does. I mean, if Zoom, I don't know if Zoom supports that.
No, we're not Zooming. We're Google Meeting.
Oh, I'm sorry, Google Meet. Is that an option on Google Meet?
I don't know. One time, Carl had like a robot dancing on his head.
That was using a Snapchat camera filter. So yeah,
Well,
you can
actually, all of those emojis are now part of Unicode. So if you can find the Unicode character, you could probably just paste it right into the chat.
That's not as good as one of the like hands up icon like this one. You know, be great if you could do that.
So David, if I'm imagining if we had like one of those that clips on your collar like that, so does that mean if somebody were to demonstrate 3 robots in a night that they could just walk up with like a 3-star general or something and have 3 stars on their.
Stick
You're
the
ready to
text
go.
out.
Found it.
Of course, the man
There
with
it
the
is.
stars. He's yeah.
There it
There
is.
it is.
All that proves is that I stole 2 bags of cookies.
My
Very
my wife
nice.
makes dog biscuits, and I think one of the patterns she has is a star. So
My wife makes banana bread. I mean, she makes dog biscuits for you?
not for me, for the
Oh,
dogs.
okay, all right.
Yeah.
Unless you're bad.
Yep.
What's your plan? They clean your teeth.
I like the one with the happy face there.
The 2 thumbs up.
The happy face had it,
Oh my.
it had more of that kindergarten, first grade feel about it
That's right.
that we're going for.
Enthusiasm, excitement. There you go. There's one with 2 thumbs up. That's a good one.
And really good teeth.
Yep.
That looks like he's thanking you for brushing your teeth.
Well, Murray, what's the text for the Unicode for the gold stars? Who's going to hand them out?
Well, I just pasted it into the chat. There it is.
Well, I see it. I see the star, but what's the text for it?
Oh, that is it. I mean, it renders. If you type U, whatever the number is, it would render like that. So.
Well, yeah. I'm looking, what's the number? You.
Hold on, I'll find it, man. Yeah, it's
Well, it would be good to have some way to memorialize who gets gold stars without having to go and look through all the tapes. You know, we might need a gold star registry or something like that.
Get it?
So you're saying it's a bragging point then, huh?
I will observe that in the pre-gold star days, sometimes months would go by without anybody turning on a robot.
Well, we could put it in. We could put it in on the link in the web page. If you know, if we just keep track of how many gold stars we give out.
There.
That's good. See, we start off by praising people who have gold stars, and then that can slowly evolve into shaming people who don't.
Oh my. My robot wants to go, David. It really does.
So I don't know how do you type that out in chats? This /U something?
Just cut and paste it. It's a character. It's like Chinese characters. It's a character. It's no different than an A or a Z or a Z. Sorry.
Nope, not that way.
It's just rendering the exact text.
Hey, not the code to generate it, but the actual
The escape sequence, yeah.
character.
Well, it depends on the computer. If you're on a Mac or a Windows, it's all different. Every computer has a different one.
But what is it on a PDP-11?
predates
Unicode by a little ways.
We just used peel-off stickers and stuck them on our noses.
If you use the U plus 2B50 and put it onto your computer, that's what you'll get.
Isn't there a band by that name? I don't know. Okay, guys, what do you think? If we run the gamut on this night's soiree?
Yep.
Before we hang off, though, I do have something I found that might be of interest.
All right, jump in.
I'll show that once I get the present now. Let's see, a Rendo. Yeah, we'll go for the Rendo. There are 2 of them actually, so I'll go with the first one and then move to the next one. They're very similar though. So I found another mini Mars rover you can print that looked pretty nice. So for anybody who's interested in printing a Mars rover, here's this one. And there's sort of the description of all what it takes. but it looks pretty good. And then, yeah, they have, as I said, it looks pretty good for description. So that's number one. And then the other one is this one. In other words, that first one inspired this guy to make this version. So it has somewhat the similar thing, but this one's actually on close. So he has a little more information detail there due to that fact. So there's this list of parts. And he used the Mega for the base. And then you get, well, there's the printed parts. And then there it shows putting it together. So there's your Mega. And let's see, and then we scoot along. And then there's the motor drivers. It has two of them. I don't know fully why he has two of them, but he did.
This has got 4 independent motors, huh?
And then let's see what's this. Okay. And that's, yeah, just the connection of the power. And they use an RC receiver, I guess, to send commands to it. For whatever reason.
Don, can you scroll by? Oh,
Yep.
maybe that's it. Murray one time pointed out that the Mars rovers that use rocker bogies were sort of split into two categories depending on whether or not they used a differential to connect the two halves. Can you tell how this one works?
Yeah, you want to see the front end.
It was
That's
almost
front end.
You
So I
can
think that's
actually-
the Fencer one.
You can tell them apart really easily, but because the back pair of wheels are on their own bogie.
Right.
That's the European style.
And it has this arm thing too. That's the main difference I've seen between them. But one has an arm and one doesn't effectively on the front.
so all all 3 wheels per side are actually on. They're not all on the same bogie.
It looks like that's the NASA style one because there's a connection between the bogies. If there's any connection at all, it'll be a rocker bogie as opposed to a triple bogie.
It's a rocker bogie. Well, I mean, you have these there can rock, and then on the front they have that other rocker.
Right.
And
yeah,
what
and if
is-
you remember, the Zero Mi or Exo Mi, I mean, has just 3 rockers and that's it. There's no differential, and there's not that kind of rocker on a rocker kind of thing like the NASA one.
So that's what I found today. I haven't really done very much other than, yeah, I found that, which might be of interest.
Cool. Nice finds, John. Thank you. All righty. Hey, well, unless anyone has anything else, I'm going to suggest that we call it an early night, get a good night's rest, and look forward to Paul. Don't forget this Saturday, self-driving trucks. This is going to be really cool. No recording, so bring your self-recording internal eyeballs to the show.
And you're able to be there on Saturdays. And that's Tuesday you're having.
Yeah, I'll be here.
Right?
I'll be here Saturday. But John and Doug, I should ask while you're online here. Will you guys be able to cover for me next Tuesday night?